Happy New Year, everyone. Welcome to spring semester 2019. So I'm going to start the year off by revisiting a topic that we didn't spend too much time on last semester, but it's important to know as we move forward. So we're working on section 4.1, end behaviors. You may want to pop open your book to this section so that you can follow along. Here we go. So there's a few functions that you already know, one being a linear function and the other one being quadratic. But what does a function to the fourth power or to the fifth power look like? And when I'm talking about the end behaviors, I'm talking about what do the ends of the graph look like? Are they both facing up? Are they both facing down? Does one face up? Does one face down? So let's explore something that you are already familiar with first. So the first function we're going to look at is one that you can do in your sleep probably. So this one is going to cross at positive 1, and the slope is 2, so you go up 2 and over 1, up 2 and over 1, and there is my very rough sketch of this linear equation. Now, there's two important things to look at when you're looking at functions. The first one is going to be the degree. So the degree of this function is 1, because that's the highest exponent. Is 1 an odd or even number? It's an odd number. And the second thing we're going to look at is the leading coefficient. Is this leading coefficient positive or negative? This one is positive. Once you know that, you now know that this function, f of x, is going to approach positive infinity as x, here's my x, approaches positive infinity. And what that means is, as x keeps getting larger and larger and larger all the way to infinity, this entire function is going to have an end behavior that's pointing up. And the same thing is, the function is going to approach negative infinity as x approaches negative infinity. And what that means is this entire function, the blue line, will be facing down. It'll be pointing down as x, which is right here, keeps getting more and more negative towards infinity. So I know that might be a little bit confusing, so we're going to do another one. The more that we do, the more familiar it will become. Let's look at this function. It crosses where? Negative 1. And my slope is negative 1/2. So I'm going to go down 1 and to the right 2. Down 1 and to the right 2. So more or less, here is my rough sketch of this function. Well, let's say I didn't know what it looks like, but I have to describe it. So let's look at the two things I said was important. The first one is the degree. The degree of this function is a 1. That is an odd number. But now let's look at the leading coefficient. Is it positive or negative? This one is negative. So since it's an odd function and the leading coefficient is negative, this function is going to approach negative infinity as x approaches. So as x is approaching positive infinity, the function is going to be negative infinity. So it's going to be facing down. And the other end of it, that's the right end. The left end of it is as the function approaches, the function is going to approach positive infinity as x, so the behavior is going up, as x approaches negative infinity. Now let's explore quadratics. So We know this is the parent function of the quadratic, and we know roughly it looks something like that. Okay, but now let's look at the degree and the leading coefficient. So the degree of this one is 2, which is an even number. The leading coefficient is 1, which is a positive number. So when the function is an even function and the leading coefficient is positive, this is what the end behavior looks like. The function is going to approach on the right, positive infinity, as x approaches positive infinity. And the same function is going to approach on the left, positive infinity, as x approaches this way, negative infinity. In other words, the end behavior of this function is on the right, it's going to move up, and on the left, it's also going to move up. Now let's look at this example. We know because the leading coefficient is negative, it's going to look something like that. So again, the degree is even. But this time, the leading coefficient is -1, which is negative. So for this particular function, this function is going to approach on the right. It's going to approach negative infinity as x approaches positive infinity. And the same function on the left, it's going to approach negative infinity. It's going to be facing down as x approaches negative infinity. Now let's go back and take a look at this polynomial function. What is the degree of this one? It's 4. Is that odd or even? It's even, like our quadratic. Let's look at the leading coefficient. Is the leading coefficient positive or negative? It is negative. Now, without using a graphing calculator, and we don't know the roots yet, we'll get to that, but I do know what the end behavior is going to look like. So, since it's an even function, and the leading coefficient is negative, I know that this function will approach negative infinity from looking at my notes, something like that, we don't know yet, as x approaches positive infinity. And on the other side of it, we know that this function is going to also approach negative infinity, so something like that, as x approaches negative infinity. Now, what it looks like in between, we will get to that. But I'm going to prove it to you by showing it to you on a graphing calculator. So here's my function, and I already plugged it into my graphing calculator, and I'm going to press graph, and that's what it looks like. Now, if you take a look at my very rough sketch here, you can see that on the left part of it, it's facing down, and then here on the right part of it, it's also facing down. So this is monitoring progress 6 on page 159, section 4.1. I would like you to write it down, and I want you to try it. Take a look at your notes. Remember, what is the degree, and is the leading coefficient positive or negative? Pause it. Okay, so if you did the work, you're going to realize that it is an odd function. The leading coefficient is positive. So looking at your notes, the function is going to approach positive infinity, which is over here, as x gets larger and larger in the positive direction, and the function will approach negative infinity as x approaches negative infinity. Now, What it looks like in between, we haven't worked on that yet. But I'm going to graph it for you, and let's see if it matches. Okay, I plugged it into my calculator. I'm going to press graph. And that's what it looks like. So, notice my sketch. On the left, it went down, approached negative infinity. On the right, it went up, and we're going to work on what it looks like in between.